What is the product of the reaction between Grignard reagents and aldehydes? What are they going to form? Now this is an aldehyde and this is a Grignard reagent. Now if these two were reacted in the presence of acid water, which might well be written as a proton in the presence of water, this would actually give an alcohol. So let's say this is one type of R group and this is another. So this is going to give an alcohol in its form. This obviously is a secondary alcohol because we actually have the carbon atom which carries the alcoholic group connected directly to two other R groups, which basically would carry two carbon atoms. So this is pretty much a secondary carbon atom. And since we have the alcoholic group connected to the secondary carbon, that will make that alcohol to be a secondary alcohol. Now, what if we use the simplest form of the aldehyde? That is going to be formaldehyde. Now, if you reacted this with a Grignard reagent in the presence of similar reagents, that is acid water, which actually serves as a catalyst, that will give you primary alcohol. This is what you're going to have. This is actually primary alcohol. Now in this video, we want to see the mechanisms which actually correspond to these products and the mechanisms that account for the answers that we would have if these two species were actually reacted together. So let us jump right into it. Now let us start with the first. Let's say we had formaldehyde. This is the structure of formaldehyde. Bear in mind there is actually a carbon atom within that position. Now let us use one example of a Grignard reagent. Let us say we use methyl magnesium bromide. Now the first thing that will happen is the oxygen with its lone pairs of electrons would actually attract the magnesium bromide. That is because the magnesium is actually more electropositive as compared to the CH3 group. So one lone pair of electrons would actually stretch forward to the magnesium metal, including the bromide group. So this whole species will leave, and this bond between the carbon and the magnesium would actually go back to the carbon atom. And this is what you're going to have. So this will be an oxygen now connected with the bromide, or the magnesium bromide rather, and you would now have a positive charge on the oxygen. That is because the oxygen actually lost some electrons. And there is going to be a methyl ion within this place. Well, I need to rewrite that. So this is what you have. This species is actually called a carbon ion. That is because it's actually negatively charged. Any organic molecule that actually carries the carbon atom containing a negative charge is actually completely called as a carbon ion. Now, in this case, this is actually a carbon ion. Now, the carbon ion is actually a nucleophile. Nucleophiles will basically attack electrophiles. So where is the electrophile that this should attack? Now, an electrophile should be positively charged. So you would therefore think that oxygen should be the point of attention. It turns out to be that that is not the case, because oxygen is so electronegative that it could actually solve its own problems. So what oxygen intends to do is to remove one bond away from itself in carbon and recreate the lost lone pair of electrons. So in essence, carbon atom which is attached to that oxygen, that is the carbonyl carbon, is actually the electrophile rather. That is the positively charged species within this system. So the nucleophile is actually going to go through this way and attack the carbon atom. That is going to cause this bond to detach and form a lone pair of electrons. Bear in mind this is actually a bond. So we need to create a bond between this methyl group and the carbonyl carbon. Now we already know that from this place there is actually 4 bonds, and carbon atom can just have 4 bonds. It cannot actually have more than that. So that is the reason why we need 1 bond removed away from here. Moreover, we know that oxygen is very electronegative, so it's actually trying to detach or remove 1 bond away from itself and carbon to recreate its last lone pair of electrons. So this is what you're going to have. So this is a CH3, and here we actually have the oxygen connected to the magnesium bromide. So this is what you have. And the next thing you need to do, you need to bring the oxonium ion, which is also called as the hydronium ion. Now this is actually something that is formed if you dissolve an acid in water. That is going to give you a positively charged oxygen connected to 3 other hydrogens. So this actually should carry only 1 lone pair of electrons. So these are the 3 other hydrogens which are attached to it. Now oxygen will use one of its lone pairs to detach 1 hydrogen from the hydronium ion, and this bond should return to the oxygen. That would recreate the other lone pair of electrons that this oxygen actually lost. So you would form something like this, and in this case I'm actually going to write this way, and you have a CH3 over here. There is an oxygen here. Whoa. And there is also a hydrogen. Now there will be a positive charge. That is because the oxygen actually lost one electron pair. So there is just 1 electron pair that is left on the oxygen. Now, next up, we're going to form water, which I might put it here. This water is going to remove this stuff away from this oxygen. And that will cause this oxygen to detach and form a lone pair of electrons. So this bond actually gets removed away from the connection between oxygen and magnesium bromide and forms a lone pair of electrons. So that gives the alcohol. This is what you're going to have. And this is the CH3 group. Now in condensed form, you're going to have a CH3 connected to a CH2, which is in turn connected to an OH group. So these 2 hydrogens, these are the ones, and this OH group is actually this species. So this is actually what you're forming. This is ethyl alcohol. That will be the product of the reaction. Ethyl alcohol is also called as ethanol. Now next up, let us look at the reaction between a higher form of the aldehydes with the Grignard reagents. So let us say in this case you actually have acetaldehyde. So this is the structure of acetaldehyde, and let's say in this case you actually have phenyl magnesium bromide reacted with the system. This is one example of a Grignard reagent, because as we know, this is an R group, this is a phenyl group, and this is the magnesium bromide which actually forms the Grignard reagent. This is actually acetaldehyde because we have this position to be a CH3 and there is a carbon atom within that position. So as you well know, the first thing that will happen is oxygen will take one of its lone pairs and detach the MgBr away from this species. That will cause this bond to return. So you are going to form something like this. So you have that there, and there is a positive charge on the oxygen. Now we're actually going to have a phenyl anion, which, as you know already, this is actually a nucleophile. And the last, well, that should not be the last. This is actually the next thing that will happen. There is going to be an attack of this nucleophile onto the electrophilic part of this compound. Now this bond will detach. So that will give us something like this. You have this. And there is a hydrogen here, and there is going to be this stuff, which is actually the phenyl group. Now, as usual, the next thing that will happen, you're actually going to take the hydronium ion and react it with that system. So one lone pair from the oxygen is going to detach a hydrogen from here, and this bond will return to the oxygen. And that is actually going to form water, which later on will be very useful. So here now we actually have this. This is going to be an oxygen with an MgBr, and there is a hydrogen over here. So this is an oxonium ion over here again. So this will be positively charged because it has actually lost one of its lone pairs. So we actually have one hydrogen here, and this is the phenyl group that we have over there. Now the next thing that happens, you're actually going to take water and react it with this. Now that is the water which initially was formed, or previously was formed from the previous step. So this is water, and it detaches the magnesium bromide away from the system, and that bond returns to the oxygen. So that is going to give us something like this. This will be a hydroxyl group, and this is the hydrogen, and this is going to be the phenyl group, right? Now, you could well rewrite it this way, and that will be pretty much correct. So I'm just going to change the positions of this benzene group, and well, this will be an OH group, which is connected to this. Now this is actually pretty much a secondary alcohol. That is because we have this position to be a carbon, and this is also a carbon. So the OH group is actually connected to the secondary carbon. This is a secondary carbon. And so that will be the answer to that particular one. So what is the name for this compound? How can you name it? So we know that this is actually a methyl group, and this is actually a phenyl group. So we could name this based on a form of ethanol. So this should be phenylethanol. That will be the name for the compound. Now you understand how to work the reactions between Grignard reagents and aldehydes henceforth. You have a nice day.